Hi and welcome. My name is Stas. I'm a Microsoft Most Valuable Professional in Azure category, software developer and cloud architect. And today you will be watching a part 2 of the tutorial dedicated to deployment of Azure Functions to the Azure Kubernetes service and using event-driven scale of the cluster by KEDA framework. And in this part we will also update our cluster with RabbitMQ instance, so we can switch from storage queue to RabbitMQ and make our application fully independent of the native Azure services. Obviously, you can deploy this application to any Kubernetes cluster that you have at any cloud or on-premises. This will be hugely beneficial if you have different clients that hosted on different clouds, and also for the clients who require some kind of a compliance and run your workloads on on-premises servers. So let's go. The next step is to create our new container and deploy it to the Azure Container Registry along with our application. So let's proceed with this task. We need to use Azure login. We need a command line. So let's use an AZ login. You have now logged in, as you can see, because I accepted login in the browser. Let's close the browser now. So I'm using just ACR login, and now as we can see our login is succeeded. We don't need to expose token really in this tutorial. Let's proceed further with ACR just to observe that no containers are there. Nothing is there. Okay. a.k.a. get credentials. Can just copy paste it and create a new container. Now it's creating. We can run Docker images to see what we have. We have several of them, but we need this one created 6 seconds ago. Let's use Docker push. And now, as we can see, everything is pushed and completed. And so we can check our repository. And we see our container here. So let's proceed with adding KEDA to our Kubernetes cluster. Func Kubernetes style namespace KEDA with the following command. Okay, we're using a dry run here because it will only generate manifest but not deploy it. Now it's generated. And we can double check it in the Visual Studio Code. Here is our application. Our local application is still running, but I will shut down it. And so we have our secrets here. We have additional configuration, and more importantly, we have a scaled object for KEDA. And to scale our application based on the requests in the queue, GitHub and the command line prompt. The next step is to deploy our cluster. So we can just type it in kubectl apply -f k8 KEDA demo YML. And let's check get deployments. Let's get our deployments. So we can stop it and check our pods. kubectl get pods. As you can see, we have our application up and running. Now let's switch to the Azure portal and find our application public IP address. Let's open services, and in services we see the public IP address that is behind the load balancer. We just click in at this address and see that our function up and running, but we need to call our function endpoint. Then we will just copy this data from the GitHub and add it here. As we can see, everything is working. Now quest calendar quest, and this is also working. And now we can additionally double check that everything is processed via storage queue results, and as you can see, everything is here. So this concludes the step 4 of our deployment. And now the step 5, we can omit this code because we already logged it in the command prompt. So we will begin with code below. We will proceed with RabbitMQ. So we have our command console. We can do the kubectl create namespace k8 rabbit. It is created. Then we use Helm wrapper from Bitnami. I already have it. We double checking that we have RabbitMQ here. Okay, we checked this. Then we run the Helm wrapper update. This is complete, and then we will install RabbitMQ with this command. This command will not use the password. So anyway, we will run it. Then we will see the status of the deployment. As we can see, it is running. And now we need to get a secret. Secret is the password, because user it's our user. We're using this output command. We copy pasting this code, opening this in browser. Here is our password. We coming back here. Now we need to use this password in the connection string format. And now we will proceed with Kubernetes configuration. Close additional GitHub, open the resource group, open Kubernetes service. As we can see here, we need to double check services. As we can see, for our RabbitMQ there are no public URL now. So we are opening the RabbitMQ configuration, opening YAML, scrolling down to the bottom and changing here cluster IP to load balancer. Obviously you should use Nginx on your local environment, but this changes is faster to deploy in Kubernetes. Service is updated. Still want us to review and save. And now we can return to our ingresses and hit the refresh. And as you can see, now we have the public IP address for our RabbitMQ. Let's open it. It will not open because we need to use port, the correct one, to log into our configuration. So we adding this port now. And here is the magic begin. We using the user, and we getting the password that we stored here. Don't save. we have RabbitMQ configuration. We go into the admin section if we need to add users. Otherwise, we need queues. Add a new queue. We will use a queue name from our deployment. It's K8 It's the same name that is located in Visual Studio Code. As we can see, the publisher outputs data to K8 Now let's give it a name, make it transient, and hit add the queue. Now queue is created. We switch into overview and going back to our GitHub account. Now we need to use this IP address and edit and configure the connection string here. We need to use this as template. Basically, this is the connection string, so we need to update it with IP address. We have login user and we will use our password here. Okay, let's keep this for now and move forward with configurations. Now we need edit KEDA functions demo.cs approach. Here we have it. It's just another dependency. We're saving everything right away. Then we need to change trigger function. We need to update the publisher function completely because our change of our trigger. I'm using the full copy paste to avoid errors. So I'm replacing this with our code. Then we will replace in subscriber function. It's still not installed. And now we need to build and start our Azure Function application. We have it running. So let's get back to our GitHub account and run the curl command. For that we will need the command prompt. And here we see that our functions are triggered properly. And now we need to build a new container with version 2 and push it to the container registry. Then generate a new manifest, double check that container version is correct, and deploy it online. Let's proceed with this stuff. And now it is published. So let's generate a new manifest. Switch back to the Visual Studio Code to analyze the changes and see that we switched the scaler to the RabbitMQ trigger. And we have correct container version v2. Now we will switching back to the command line and deploying. And now we will look into deployments. Everything is correct. Now we have the RabbitMQ running because I already triggered this test, and here we will have another message soon. Here it is. But this is not the end. We can also install the artillery and run a quick test against our instance. Now as you can see, the number of messages rising. So it's 2000 messages here. And as you can see now, the process is starting to unload the messages from the RabbitMQ to K8 queue results here. So this is the slow process because I have only few nodes allocated for this stuff. So let's recap a little bit. Our functions can be run on Kubernetes? Definitely yes, it's working perfectly, and even with this lightweight demo you can build a proof of concept that everything is fine. Are functions better in Azure? It's also yes, because it's cheaper, it's more powerful, it's a lot of features that you will miss on the Kubernetes. Are functions application the cloud agnostic? Definitely yes, because you can run Azure Functions on GCP and AWS. And the last but not least, do you need two solutions for on-prem and cloud? I don't think so. You can solve your issues with this as easy as it gets. So, thanks for visiting and cheers, bye.